record on this computer. Great. So let's see. So you probably, if you haven't gotten the email or haven't heard, right, Temple says, you know that whole stopping classes, in-person classes for 2 weeks? Well, that's now actually the entire semester. So that really doesn't change anything for us. That's going to be online. You know, I plan on doing that. I really do appreciate that people have gotten into that. My choice of virtual background has prompted you guys to put in some awesome virtual backgrounds. I really appreciate that. Really livens it up. And also now that I've got a better grasp of the limitations of breakout rooms during our lab sessions on Fridays and Mondays, right? My intention is that I would help the TAs and jump between the labs, but that doesn't seem to be feasible. So what I'll do is I'll join in the beginnings of the labs and make sure that that there aren't any technical difficulties at the beginning of the labs, or to help answer any questions at the beginnings. And then around 10 o'clock during your lab, I'll probably open up my own Zoom session to help with any backlog of demos that there are. So at that point, I'll announce on Discord that basically my room is open, my Zoom room is open, and you can click it to join so that I can so that you can demo your work. That way the TA can be focused on helping people who need help. Make sense?
Yes.
So that way I'll be able to handle your demos. If you have questions that you don't think the TA would be able to answer, you'd be able to join there, but that would be explicitly timed that I'd be helping with demos. Let's see. Also, as I mentioned, I'm thinking about probably doing either Sunday or this upcoming Monday, which I believe is Labor Day. I'll probably live stream a game on Twitch, probably Hearts of Iron 4. Attendance totally not required. But if you want to join and watch that, I just figured that'd be something fun to do for people, and just to help, you know, promote a sense of community, and you might actually learn something about World War II history. I think I'm just going to do single player for this one. You can message me more about that later. We'll talk about the gaming later in the gaming gaming channels of Discord. So we can talk about that more later. But yeah, Peter's got the right of it, Pac-Man. We'll talk more about that later because I don't want to eat too much into class with miscellaneous stuff. So that's that. Now, finally, let's talk about the quiz that I posted last night. First off, it may blow up. The quiz just may have I've already had 2 emails about unforeseen issues, just simply with issues with the quiz, like with some of my checks. The way the quiz works. So first, let me pull it up and show you where to find it. And then, of course, I should probably share my screen because otherwise you're not going to be able to see anything. Screen 1. Currently, I'm working off my laptop, which means that everything is just going to kind of look big, just because of the way I've got my configuration set up. So let's go to Python. And here we are going to go to modules. Again, to find all of your information, my goal is going to be able to just click on the module overview and it's going to have the links to everything. I'm going to try to work on module 3 tonight, so all that information is going to be available for us. You can go ahead and move the chat window down here. Okay. So click over here and write videos, readings when they're due. Exercises are due Saturday evening. I've got this lab is due whenever that said it was, to be honest. September 8th, it's plenty of time. And then here's the quiz due at the end of the day on the 6th, which means I think I set it for 11 o'clock. So I don't mind I'm showing you the first question. First off, the way the quiz works, because again, this this first quiz is to kind of show you how it works. So actually, I'm going to skip to question 2 here. So here we've got, I'll skip to question 1. So question 1, whatever. So here, first off, this is a timed quiz, but it's not got a hard time limit. Instead, what we've got is a button with, oh, it's really choppy for you? Okay, I might have to relocate. Let's see. I'll keep monitoring and we'll see. Okay, sorry. All right, you know what? Rather than just spamming chat, let's go into the participant windows. If you are having issues with my stream, hit the no button. If you're having issues with, if you're doing fine, hit the check button. Hit yes for good, hit no for bad. Yeah, go click participants. It should be on the bottom with the icon with the people on it. And there's a bunch of selections such as yes, no, go slower, go faster, as well as the ability to raise your hand, virtually raise your hand, as well as clap or say you need a break. Anyway, so just simply hit yes if you're having, if it's going fine, no. So, and someone pointed out it might be 1300 Wi-Fi. Yeah, there could be, if you're all in the same area, that could be issues, but the vast majority of class seems to be going fine. So at least I know I don't have to, okay, well, good thing I'm recording then. So at least I know that it's not, you know, a positioning thing on me. Okay, so, so the way this will do is that this will, oh, where are recordings? Excellent question. Recordings for the lectures can be found by going to the front of the page and hitting over here and straight in the middle, lecture recordings. And it will have a playlist, which I try to keep up to date of all of our recordings for the lectures. Okay. The way this quiz will work, okay, is that it says the late penalty will take effect after 45 minutes. So after 45 minutes, that's when I'm going to start doing that whole late penalty. It shouldn't take you 45 minutes. It shouldn't take you nearly that long. I just wanted to put in a nice, good amount of time. But the way this works is that you've got you'll have a start button here initially. And when you hit start, it will reveal the questions for you. You can go through the questions like this. You can pause your quiz actually, which is pretty awesome. It will just pause the time and it'll hide the questions from you. So that's a really nice feature if you need to take a break or something. And it won't kick you out after a certain amount of time. Once 45 minutes, all this is doing is just keeping track of how much time it took for you to take. And so any late penalties, that would be applied manually by us, but that's probably not gonna happen for this quiz because this quiz is the first one and I just want to make sure everybody gets that. These ones will be, so anything where you have code, such as, that will be automatically graded. I'm not sure if you can leave and come back without penalty, but you can pause it and leave, right? I don't know if you can close the window without penalty, though. If that makes sense, right? You can't close the page. If there's issues related to that, though, you can tell me, you can send me an email or a message on Discord and I'll be able to reopen it for you. Doesn't make it easy for me to do like multiple attempts on this thing, but it's got the rudimentary features that I need. But if you need to leave, you can pause and come back. I just merely ask you don't abuse that. Like it seems pretty abusable. So yeah. But anyway, the main benefit of this is that you can code stuff. It will auto grade it. And if there's an issue with the auto grader, I'm going to figure out a way for the best way to communicate that rather than getting like a million emails in Canvas. So if you have issues with this, we'll figure out a way to do that, but don't worry if something needs to be manually graded, that's fine. Okay, so just because the auto grader gets marked something wrong doesn't necessarily mean it's wrong. It just means that the test I wrote may have messed up. Ah, yes, is it open book? So according to our syllabus, all quizzes are open, non-human resources, right? So what this means is basically, I'm just going to make the assumption that that trying to prevent like students from using resources like the internet, it's a lost cause. Why bother? And besides, when you code, you're going to have the internet open anyway, so it's kind of a false dichotomy. I feel like it's unrealistic. So all I'm asking is basically, you don't go on Fiverr, pay somebody to do it. You don't go on Chegg, post answers and hope somebody answers for you. So to summarize, looking on Stack Overflow for something to help you, perfectly kosher. Going on Stack Overflow, posting the question and asking for an answer to it, that's a no-no. That help? Right, so if the book grader marks something wrong, that isn't wrong, just email me, because that way, that will let me know to manually grade it. The idea here is to reduce the workload that me and the TAs have to do with manually grading stuff. I would probably prefer Discord. I'll probably set up a channel specifically for complaints, let's say, or issues with quiz grading. So I will let you know the preferred way to do that, but it's just, I just don't want to necessarily gum up all the email with please regrade this or stuff. It gets a bit overwhelming. So many emails these past 2 weeks. All right, so anyway, it's due 11 o'clock, 9/6 at 11 o'clock. I assume that's Eastern Standard Time. So you can take it at your leisure. Oh, that's 11 o'clock in the evening. So again, just take it whenever, just before this time. It's a soft due date. So if you have to take it afterward, that's fine, let me know, but there will be a late penalty if there's like not a good reason. Okay. Good reasons include my house burnt down, or I'm sick, or I lost power, stuff like that. All right, so that's what we've got for today. So let's go ahead and talk about what we want to do for today's activity, which is that I would like to ask anybody, I'd like to ask the room, is anyone familiar with Fermi's Paradox? Anyone? All right. Anybody who's familiar with Fermi's Paradox, you are more than welcome to unmute and take the floor to explain what it is.
Professor Rosen, is that the alien theory, why they haven't contacted us yet?
It's more of the question, but yes, go ahead. You elaborate?
From my understanding from the documentaries I've seen, it's all the evidence that has been presented to us that there's life out there in the galaxy based on the Drake equation, yet nobody's contacted us yet, and it just doesn't make any sense.
Yep. So simply, or to go into a bit more detail for people, there's this equation which we're going to look at today called the Drake equation, which simply says, hey, there's billions of stars, and let's just go ahead and assign arbitrary values for how likely it is for life to form, and basically how long a civilization, the likelihood a civilization gets to the point where they can communicate in such a way that it would be able to emit itself and we could detect it, right? If we plug that in, because there's so many stars and so many planets, there should be plenty of civilizations out there. So the Fermi Paradox is basically the question of, well, okay, where are they? And this is actually quite a fun equation to look at, just to look at. And it gets into today's assignment, which is all about wild mass guessing. So let's go ahead and look up the Drake equation on Wikipedia. By the way, I love Wikipedia. I'm going to go ahead and share my screen. You might not hear Professor say that too much, but I love Wikipedia. It is great. And although I do agree that you should not cite it when you are writing papers. Why shouldn't you cite it? Because all encyclopedias are what we call tertiary sources. And when you're writing research papers, you do primary or secondary sources. So anyway, there's an actual legitimate reason. So this is the Drake equation, and it's just a bunch of symbols, right? The made up symbols that have names attached to them. So let n be the number of civilizations in the galaxy that we could possibly communicate with. And then here's how we figure that out. We're gonna take the average rate of star formation of our galaxy, and then what fraction of those stars have planets, and then those the number of planets that are habitable by some form of life, right? Then the fraction of planets that could actually that support life that actually develop some life, and then the fraction of those that go on to develop intelligent life, and then the fraction of civilizations that actually makes it to the ability to send out radio waves, and then the length of time which they would be able to transmit radio waves for. Now, there's a couple things to understand here. Space is big and time is big, really, really big. In fact, if you ask an astronomy professor, they would probably love to tell you all about this. But here's the original estimates, and he basically said, hey, we get 1 star a year over the life of the galaxy. This was regarded as pretty conservative. A fifth to half of all stars formed will have planets. Yeah, we might be wrong about one of the variables, but also you don't have to be. Space is huge. The amount of time it takes for any kind of communication to get to us is huge. So like, if you look up at the star in the sky, it's possible that the star you're looking at no longer exists because it's that far away, and it could have gone nova at that, quite some time ago. So let's see, the number of planets, right? These are all just kind of fractions. And basically it said do 20 of them. But this is just kind of back of the envelope equations. I mean, and yeah, we could have a huge debate about this, whether or not we're the only, and actually both answers, whether are we alone in the galaxy? If yes, that's a fascinating answer. If no, that's also a really fascinating answer. They both have really fascinating implications. But basically, this is kind of the back of this equation isn't like a scientific thing. This is like, these are physicists making stuff up, right? So making wild math guesses. So we're gonna look at, in today's assignment, of how to make these kind of guesses. So with that, let's open up the textbook and go to the third project, how many handshakes? So I'm going to go, and this is one of the great things we can actually use Python pretty well for, which is that we can use this to do calculations to solve some problems. So we can let's go ahead, and I'm actually going to open this and drag this down here. All right, one sec. Just taking, why did it not show up? Okay, there it is. And now I'm going to take it. I'm basically making use of the fact that I have 2 monitors and I can have a second set of notes. So there we go. And now I'll just simply open the page without the notes over here. All right, so let's take a look at, so one of the things that we want to do is that's a very useful problem-solving tool that really doesn't get taught because it's really hard, and it's a very unscientific way to do it, yet scientists use it all the time, which is making really interesting guesses about data. So one of my favorite things on the internet is XKCD's What If. Which answers ridiculous questions about absurd hypothetical questions. So this one's pretty cool. If all digital data were stored on punch cards, how big would Google's data warehouse be? And the idea here is Google probably has more data storage than anybody on Earth. But there are some people who might have more, the NSA, the NRO. Anybody know what the NRO is? It's one of the big 5 intelligence agencies in the US, surprisingly. Yet I really didn't know about that until I started getting into really weird stuff. Really weird RPGs like Delta Green. Any answers about the NRO?
It's the National Reconnaissance Office.
Yep, National Reconnaissance Office. And if you're wondering what they do, they're satellites. All the U.S. is basically using spy. Can we please leave the Elon Musk slap fight for another time? He is definitely a controversial figure who has also done a lot, but we can all agree that he's a jerk.
He probably does not agree with that.
He probably does not. My wife says he probably does not agree with that. This is the U.S. mapping, U.S. military's mapping service. They probably have as much data, and then all these places. So basically, how much data does they have? So he basically breaks down this problem by saying, okay, so we got to follow the money to look at that. They have about $12 billion. Their biggest data centers are $500 million to $1 billion. So they can't have more than 20 of those. And on their website, they say they have 13 data centers. And then they probably have some other ones. Probably definitely near Atlanta, Georgia, plenty of smaller stuff. And then they can look at how much data they are using. They use about 258 megawatts of power. How many computers can they run with that, right? So he looks into that stuff and says, okay, a server takes up about 215 watts. So if we're looking at 258 megawatts, these numbers, believe it or not, are roughly the same. 215, 258, there's not too much of a difference between them. What's different is the unit of magnitude, right? Everybody understand that? That these two numbers aren't, right? 258 versus 215, that's not the big difference. The big difference is megawatt versus watt, right? Millions of watts versus watts. So simple, so don't even bother trying to come up with fractions, just simply say, that's about 1 million servers. Does that thought process make sense? And then how much, then trying to figure out if we, so then what he does is that he says, okay, so we know how many servers there are, right? We're trying to figure out how many punch cards Google has. If we took all the data Google has and turned it into punch cards, how much data would that be? So the question, so we first figure out how many servers Google has. Let's say we can estimate about 1 million. So how many terabytes per server? Conservative guess, 2 terabytes. That seems like a fair guess to me. So 2 terabytes times 1 million servers, that's 10 exabytes of data, which is huge. And says that here and it seems realistic because the commercial hard disk industry creates about 8 exabytes worth of data drives annually. Anyway, so let's assume that basically that comes up to maybe 15 exabytes total. So how much does a punch card hold? Does anybody know what a punch card is? Anybody want to take the floor on that one? What is a punch card? Probably should have led with that.
It's something you use to back in the day you would use it to like clock into work if you're working an hourly job.
Ah, close. But no cigar. It
And
is.
your house is on fire.
It's fine. This is a punch card. This is how programs used to be written. Back before you could actually type stuff into a computer.
Were they started by something Lovelace?
I don't think necessarily Lovelace started them, but they were the Hollerith card, Herman Holler,
Oh, okay.
for the U.S. Census.
Oh.
So here's a deck of punch cards for a computer program, and God help you if you drop them and didn't label them in order. But those cards would be punched, and that's essentially a computer program, and those would contain the instructions. A punch card holds about 80 characters, and a box of cards is about 2,000 cards. By the way, a character is about a byte of data, just FYI. So you point out that 15 exabytes of punch card basically would cover New England in 4.5 kilometers of punch cards. So let's go back to this exercise, which is actually pretty fun. Okay, so let's take a look at maybe walking through this, which is how many minutes do we have? Is it going to take until we get to fall break? Right. Here's an example of that kind of pattern we have. We can say enter the number of years, and we'll tell you how many minutes it is. Right. We enter maybe 3 years. We take the number of years, multiply it by 365. That's how many days there are in a year. Take the number of days there are in a year, multiply it by 24 to get the hours. This should look familiar to the lab. So 3 years is 1.5 million minutes. Oddly, that seems kind of short. So, so how would we go about basically saying, hey, I'd like to calculate how many minutes there are left until until fall break? What should be the first step do you think we should do? Anyone want to take the floor or
calculate the days?
Calculate the days. I mean, days are a bit hard to count though, right? It's a bit tedious. What's a bit easier than days to count?
Months.
Yep. Weeks. Weeks is easier to count the days. So let's go ahead and start by asking, how many weeks are left until spring break? So, 1 second. Yeah, so how many weeks are there until break? And if somebody would be so kind to look up how many weeks are left until fall break, that would be awesome. See, fall break, actually, I could probably do that. Copy. Paste. So, there are how many weeks until the break? 11. So, okay, we'll put in 11. And now that we know how many there are, let's go ahead and create some constants. Days in week is equal to 7. When I put something like that in all caps, by the way, I'm creating a constant. That means that I'm not going to change it. So let's figure out how many days there are until fall break. Num days equals weeks times days in weeks. This is just kind of a stylistic thing to do in all caps. Again, that just means that's telling any other programmer, don't change this variable, and I'm not going to change it either. Print. And let's go ahead, and actually I'm going to copy this line over here, and I'm going to go ahead and run this. So somebody said 11 weeks? 9 weeks until that seems right. 9 weeks until fall break.
Before you run,
No,
you have.
I know.
Okay.
It's intentional. So there are 9 weeks until break. Error. Okay, days in weeks. That, days in week, save and run. That was not the intentional error. So let's say 9.
That's what I was going to say.
And now it says there are 9,999,999 days until. That seems a bit much, right? I know that 2020 seems like it's going on forever, but is it really that much? So what happened? What did I do wrong? What did I mess up?
You didn't change it into an integer. It's
That's
still
right.
a string.
I didn't change it into an integer. So weeks is a string over here. So when I do so when I do weeks times days in week, it turned itself into, it turned itself into, it basically replicated the string. Basically said, do this 7 times. So that was no good. So the way we can fix that is that I can toss it into an integer and make it an integer right here. It's a very common error. It's one that the book suggests making intentionally, and I would have done anyway. Intentionally, I mean. That's my story, and I'm sticking to it. How many weeks until break? 9. So if there's 9 weeks until break, there are about 63 days until break. And now we can kind of break it down from there. Int, let's see, so num hours is equal to num days times 24, right? We can move on here. Num hours is equal to num days times 24, and then we could say num minutes is equal to num hours times 60, and so we can then do minutes. And if there's 9 weeks until break, then we just can simply put in 9. Doesn't seem like too many. All right, so now I want to give you your turn, which is to do the following. How many trees? This was an annoying kind of style of interview question that people would give for programming stuff, but it's a fun thing because it's this entire guesstimation thought process, which is asking the question, how many trees are in the state of Washington? It's an impossible question to answer correctly because there's no freaking way to do that. You can Google something like that, but aha. So Rob basically said, find out the average trees per an acre. That's a great question. That's a great way to go about it. So, so this is what I'd like you to do. I'd like you to, I'm gonna split you up into breakout rooms for 10 minutes. Just gonna automatically assign you to these breakout rooms. And I want you to try your best to come up with an estimation in 10 minutes. And then I'm gonna ask various of you to do that. So sorry, I've already stopped sharing. I'm not really sure what you want me to do, but I want you to try your best to basically come up with some answer, work together over the next 10 minutes to come up with some answer, some reasonable estimation of how many trees are there in the state of Washington. happy feet. Ugh.
About 1/8 of an acre.
Mm-hmm.
We have one large tree.
Uh-huh.
We have room for 2 or 3 others. So let's say there are 32 trees per acre.
Mm-hmm.
And there are 45.672 million acres. I would extrapolate that.
Mm-hmm. That's what I'm looking for. Pause the recording. Okay. Let's go ahead and bring everybody back.
Puppy dog.
This is Happy Feet, by the way. I had to move the camera down so that it would get her. Yes, I love you too, Happy Feet. She's a fairly old dog. She's a King Charles Pekingese Chihuahua mutt thing. She is blind in one eye. In fact, we had to get it removed last year. It was a congenital defect, but she's always been extremely happy. Although, interestingly enough, with only one working eye, she's always been hesitant to step over any perceived barrier on the floor. So, this is Happy Feet. All right. So,
I have a question.
Sorry. Yeah.
In the online on Runestone, in the box where you code, how do you do the indentation?
Right now, since you're not doing any loops or anything, you shouldn't have to do any indentation.
Oh, okay. Because for the handshakes problem, I thought I would have to have a
for
statement.
loop might be useful, but we can see. I mean, that's what we're going to work on next. But right now, I'd like people to discuss. I'd like if anybody would like to step forward and discuss what their estimations were and what their problem-solving processes were. If anybody wants to go ahead and share, put themselves on the spot. I mean, I would say there are no bad answers, but saying there's at least one tree is probably a bad answer.
Ooh, I can go through my problem-solving process for that, I guess.
Sure. Would you like to share your screen, or do you just want to?
Oh, well, I actually didn't get it took me a long time to find the numbers because it's hard to Google stuff, but I could say what I was going to do.
Sure. Please go forward.
Yeah, sweet. So first I had Googled the number of average number of trees per acre in Washington, and it gave me this one result that said there's approximately in Western Washington there is 198 trees per acre compared to Eastern Washington, which is 150. So I got the average of those two and just computed the 170. After that, I looked up the the number of, where is it? The number of acres that are in Washington, which is 42.5 million. And then looking at what I was going to do was using a similar method from the first program with the years and inputting that. Swapping out the years with a variable called TPA, so trees per area, and the user can input either the 150 number if they want to get Western, 190 number for Eastern, or the 170 for an average. So that'll be mentioned.
Get a final answer? So did you get an estimation?
Well, for the estimation, I just multiplied the two numbers for in my calculator, and that estimation was, I feel like this is a high number, but 7 billion. Wait, yeah, that's a billy. 7,225,000,000.
That actually seems like a fair estimate to me.
Yeah, I don't know how many trees there are. I'm not a very arbol kind of guy, you know.
I mean, compared to other estimates I've seen online, the estimates are in the billions.
Oh, sweet.
So anyone else want to share?
I found, so my work process was similar to that, finding the average number of trees per acre and then finding the number of acres in Washington. A difference in how my work ended up going was that I found a website called workingforests.org, which says that in Washington, about 23 million of the acres that make up Washington are forest. There's about 47%. So I used that instead of the full number of acres for Washington, and got, what was my final answer? I got a number of 3,910,000,000 number of trees in Washington.
I actually asked my wife before she headed out to give me her thought process on it, and I will share it with you, which is that we live on about 1/8 an acre, and we have one big tree. And so kind of just looking around, I'm on 1/8 of an acre, could probably fit 32 trees in here, and she just basically extrapolated from that and got to about 1.5 billion trees. You know, so that many acres, how many trees per an acre, how many trees per an acre in Washington. I mean, they're pretty good those are all valid ways of getting to basically close to 1 billion trees. If you were above 1 billion, like in the tens of billions, probably fine. Hundreds of millions, you were slightly off, but the thought process was there. Hundreds of thousands, probably not so much, but that's okay. So what I want you to do is just save your estimation or your estimation thought process in the Python code. It will give you credit basically for whatever you put in, but this is, again, I'm trying to build up thought processes here, less about the coding at the moment. So let's continue on with the second and final part of today's work for our last 20 minutes, which is, sorry, I have to open this back up, input, compute, output. So share, screen 1. All right, how many handshakes would it take for everyone in your class to shake hands with everybody else? You should not have to shake hands with you should not shake hands with anyone twice, and you don't have to shake your own hand. Right? So the secret to figuring this out is to start small. How many handshakes would it take if there were only 2 students?
1.
1 handshake. What if it was 3 people?
6.
Let's see. So, it would be. A would shake. So you have Alice, Bob, and Carol. Alice and Bob, Alice and Carol, and Bob and Carol. That'd be 3. I would think.
Wait, but doesn't every person have to shake 2 other people's hands?
They have to, okay, excellent point. But it's, if I shake hands with, the answer, Ryan, is practice. thinking about these weird kind of things in statistics class. So, so if Alice shakes hands with Bob, and Alice has to shake hands with Carol, right? Okay, follow so far? But Bob has to shake hands with Alice, and Bob has to shake hands with Carol, right? But Alice has already shaken hands with Bob, right? Alice shakes hands with Bob is the same as Bob shaking hands with Alice. So if we do 6, we're double counting. Does that make sense?
Oh, yeah, right.
But
Yeah,
that kind of gives us to a good equation, right? Alice would have to shake hands with everybody else. Bob shakes hands with everybody else, right? And then the answer we needed was half that. Let's go ahead and see if we can't use that with 4, right? 4 people, I need to shake hands with, whoops, you okay, Happy? All right. So we got 4 people, Alice, Bob, Carol, and Dan, right? Alice will shake hands with 3 people. Bob needs to shake hands. So they all have to shake hands with 3 different people. But that's more than we need. But that's an overestimation, right? Because that would be double counting, right? If we did 3 plus 3 plus 3 plus 3. But as somebody pointed out in chat, it would be 4 people. It would be 3 plus 2 plus 1, right? Right? Alice shakes hands with 3 people. Then Bob has to shake hands with Carol and Dan. And then Carol has to shake hands with Dan. And that's about it. Right. So we could possibly do that. So that seems like a pretty good equation, which is that we could say that the number of shakes we would need to do is, right, essentially the number of people squared divided by, so if n people need a shake, n minus 1 squared divided by 2. N times n minus 1 divided by 2. Yeah, that's the formula that it works out to. And if you're wondering where Cameron got that formula from, Cameron, did you take Calc 2? Math major, right. So, but this is the kind of estimation. So, but again, we're just trying to figure out an estimation here. So once so go ahead and try to nail down this pattern for this last part. Figure out what this pattern is. It doesn't have to be exact. That's the thing about estimation. They don't have to be exact. They just have to be close. Right? So the question is once you got a pattern, try writing a program to ask the user for the number of people and then compute compute the number of mutual handshakes you need. All right, so I'm going to split you back up into breakout rooms, and then I will bring you back in the last 5 minutes of class. Stop share. Sorry, my windows are in the way of me hitting the appropriate button. All right. Recreate the rooms. I'm going to go ahead and recreate it. Your new rooms. And okay, adios. I'm just, see, you did not like that, did you?
There it is. Sure. This is what we came up with right here.
Right. So yeah, n times n minus 2. So why n times n minus 2 as opposed to?
Oh, my bad. That's
typo.
Yeah, typo.
Yeah.
I did integer division because it was giving me decimals. I thought it'd be better to do integer.
All right, so let's go ahead and do, let's see. So the 100 and, let's go with 138, which is ostensibly how many people I think are registered for this class or something like that. So 9,453 handshakes.
Wow, that's a lot of code.
I mean, mind you, you each would only be responsible for 137 of them. So, you know. But yeah, the math part is a bit difficult, but noticing if you didn't know the math, that's fine. It's more about the thought process that went into solving the problem that I care about. So I'm going to, I think I'm gonna leave this room and then break the breakout rooms.
Gotcha.
I'm just waiting for all the breakout rooms to close. So the important part of that exercise was less about getting the right mathematical answer, but more about the thought process about how to go around solving it. The equation that people posted in chat, n times n minus 1 all over 2, that's something that I'm very familiar with because of my experience with 2168, where that comes up with a whole lot. And you learn about that equation in calculus. Does anybody want to go ahead and share their answer or share what they have? Any volunteers?
I'll go.
Okay. Let me enable screen sharing and you can go ahead.
Is it enabled?
Yep.
All right, cool.
Should be.
All right. So before we went into the breakout room, I saw there was 136 people in the Zoom right now, so that was the number I based it off of. And when you do that, you get 9,180 handshakes.
That's pretty cool. So the equation comes by, so where does n times n minus 1 over 2 come from? Do you want to explain that, or would you prefer me to do that?
You should do that one.
All right, so n times n minus 1 over 2 is, as Cameron just posted in the chat, is a series. And the idea here is that basically we needed, if there were 2 people, there was 1 handshake. If there were 2 people, it was 1 plus 2 handshakes. If there were 3 people, one person had to make 3 handshakes, then the other ones had to initiate 2 handshakes, and then the last person had to initiate 1 remaining handshakes, 1 plus 2 plus 3. The pattern 1 plus 2 plus, and this just continues. If you have n people, then one person has to make n minus 1 handshakes. Another person let me go ahead and stop sharing I need to terminate that. Or you can do that on your own.
Yeah.
Another person can do, so if you have N people, then one person has to initiate handshakes with N minus 1 other people. Then another person has to initiate handshakes with N minus 2 other people. Notice I say initiate because, again, it's that entire reflexive thing. Me initiating a handshake with you means that you don't have to initiate a handshake with me later because we've already shaken hands. No need to double count. So, and if there's some math involved that can be shown with something called proof by induction, but again, that's not in the purview of this class. What is in the purview of this class is doing something called Googling. And if we look at that, 1 plus 2 plus 3 plus 4 ... plus n and hit the magic Google button, we see this one. And it says, hey, the n partial number of the series is basically it's saying that this entire idea, if you cap it at n, is equal to n times n plus 1 over 2. So, see. Interesting though that that basically a lot of people were doing n times n minus 1 over 2. So why the difference? Well, the difference was is because we had n people but we had to take one out. Negative 1/12, though, that's a very interesting thing. That's if it goes to infinity through zeta function regularization and Ramanujan summation. And if you don't know about Ramanujan, take a bit to look him up. Kind of a brilliant guy. And it's very interesting. But this is the important part. That's where it came. This is where that comes from. That equation comes from. All right. So with that, it is 3:20, which means class is over. Right. That's exactly what the answers are. You don't shake hands with yourself. Nobody shakes hands with yourself. That's why we had n times n minus 1 rather than n times n plus 1, because we subtracted 1 from both the ends. Peter says he accomplished shaking hands with himself. I'm very impressed with you, Peter. All right, so class is dismissed. For this one, be sure to submit whatever code you have, as well as participate in the surveys to get in the polls at the bottom of the project page to get full credit. All right?
Professor, just a
Yes.
quick question. What's the difference between input and raw input?
More than I would like to go in over here. I'd actually have to double check that. Input, though, takes it as a string. I would avoid using raw input for right now. I will tell you what it is in just a second because I honestly have to double check.
Yeah, because that's how we learned to use raw input for integers in high school, and I tried it here, but it didn't necessarily work, so I used the int input.
I prefer doing input because it's always going to be a string.
Since it's Python 2, that makes
Python
sense.
2 got rid of it, it says. So, sorry, Python 3 got rid of it, it seems like, so that's...
Okay, I got you.
Yeah. Raw input was renamed to input. That's why I was like having some issues with this. I'm like...
Okay. All right. Thanks, Professor.
Okay.
I have a question.
So I have oh, sorry, you can go first.
No, you go, you go.
I have a question about the chapter 2 exercises. For 12 percentage 15, like I don't understand how to get the answer for that.
The what? I'm sorry?
For one of the questions, it's like, you know, like when you type 12 and then the percentage sign and then the number 15, like I don't know what the answer would be for that, for like the remainder.
Okay.
Modulo
So
remainder?
when you do modulo. So when you do a small number modulo by a much bigger number,
Mm-hmm.
the remainder is the original number, right? So what is the remainder of 10 divided by 100? Well, the quotient is 0 because 10 divides 100, because 100 can go into 10 precisely 0 times. It's just too big.
Mm-hmm.
And
Oh,
there's 10
okay.
left over.
Yeah, I tried 0 and 0 doesn't work.
Right. 0 is what you would get if it's evenly divisible.
Oh, okay. Okay. So then it would just be like the original number then.
So,
okay.
Right, it's A mod B is equal to A when B is much bigger than A.
Okay. Yeah, it works. Okay, that makes so much more sense. Okay. Thank you.
No problems. Let me go ahead and stop recording.